This lecture is about power system analysis and stability introduction. So in this introduction we can see about general perspective and overview of power system, need for system planning and operational studies. So before going to the power system analysis and stability, we must know what is a power system. It consists of generation, transmission and distribution. And what are the components of power system is about generator, transformer, transmission lines, distribution lines, loads and compensating devices like shunt, series, static or compensators. And the function of a power system analysis, it needs need to monitor the voltages at various bus voltages, various buses, real and reactive power flow between the buses. And not only this, to design a circuit breaker according to the rating of the bus. And we have to plan for the future expansion of the existing system, and we must analyze the fault under different conditions of three-phase fault, line to ground fault, double line fault and line to ground fault. And we must study about the small and large disturbances also. And what is the need of power system analysis in planning and operation is a system planning and operation covers the whole period ranging from the incremental stage of system development, and it requires the area, spacing, regional load dispatching center, national load dispatching center for the dispatching the power, and total load, total demand is equal to the sum of the real power generation to meet out the demands, and we have to generate that much equivalent power for generation. System must be reliable and uninterrupted. So all the time, every seconds it should not be interrupted, and at the same time it should be reliable and required to maintain overall system like generation, transmission and distribution. And dealing with the power system analysis, we must know about what is a load flow analysis or power flow analysis, short circuit analysis and stability analysis. And load flow and power flow analysis, so we must know about what is the system stability to determine the voltage, current, active and reactive power flow in the power system. And it should be operating conditions can be analyzed, such as loss in generation, losses in transmission lines, losses in transformers or the loads, and what are the equipments overloaded and unexpected voltage levels we must know to fix the optimum size and location of the capacitors for improving the power factor. And load flow analysis is used to evaluate the effective of various loading conditions of a system. And one more is a short circuit analysis. This is a short circuit analysis have a multiple increase in current and forms an abnormal system. And to find the magnitude of a current flow in the system at different intervals of time until it meets the steady state. And there will be a types of fault is also there like symmetrical faults and unsymmetrical faults. And we must rescue the system from the fault condition. To analyze this short circuit, symmetrical components and sequence networks are used by this short circuit analysis. And next one is the stability analysis. It is very important the types of stability analysis about steady state and transient stability. So the stability depends upon the power flow pattern, generator characteristic, system loading level and line parameters, etc. So the stability analysis, it consists of steady state and transient state. So steady state stability is about the power system remains synchronism and follow the relatively slow and load change. And the transient stability is about the power system remains synchronism under large disturbances. And this is the structure of a power system. So in this power system, the generation station has a voltage level of 11 kV. It will be generated, After the generation, it is step up into 11 kV to 220 kV. So after the step up of the 11 kV from 11 kV to 220 kV, it become taking place of primary transmission for high voltages in long distances, and it will be received at receiving station, and here the step down transformer is used from 220 kV to 33 kV. And we have a secondary transmission. It's like a feeder, and it is received by the substation about the step down transformer from 33 kV to 6.6 kV, and this voltage will be largely used for bulk consumers like factories and industries. Again, this voltage is again it is step down into used for primary distribution, and it will be step down for distributed transformer with the help of from 6.6 kV to 400 voltage for 3 phase, or 230 voltage for single phase. So the secondary distribution is taking to all the consumers to the service mains with the help of distributors. So in this structure of power system, we have a generator. It converts the mechanical energy to the electrical energy, and we have a voltage level of 6.6 kV, 10.5 kV, 11 kV, 13.8 kV and 15.75 kV. And the transformer, why we are using transformer is transfer energy from one circuit to the another without changing the frequency, and we may change the voltage and current level. The transmission lines power transfer from one location to the another. The distribution lines distribute the power to commercial, domestic and small consumers. So we have a two primary transmission line and secondary transmission line. So primary transmission line have line 11 kV to 110 kV or 132 kV or 220 kV at different levels. So the secondary transmission from step down value from 66 kV or 33 kV or 22 or 11 kV. And we have a distribution also, primary distribution and secondary distribution. So the primary distribution has 3 wire system, 33 kV or 66 kV feeder. This will be used by industries or the companies. The secondary distribution is about 400 voltage for 3 phase and 230 voltage for single phase. This is for the consumers. So this is the structure of a power system. The entire system will be given. The first one is power plant, and step up transformer is used. Finally it is given to the transmission line, and this will be a high voltage transmission line. It can be transferred from one place to another in a long line. Another one is a step down transformer. In this step down transformer, substations are used. In this substation step down transformers are finally used, and it will be given to the consumers. And the equivalent single line diagram is also given here. So about this basic introduction part is over. Thank you very much.